Back up a little bit and talk about GE. We are a company that's going digital industrial. What does that mean? We're an old, over 100-year-old industrial company that is transforming into a software company. So we manage everything from turbines to jet engines to MRI machines, but we're also starting to make the software for those particular devices, as well as I would say the support behind them as well. Our attack surface is huge in terms of industries. We support everything from aviation, healthcare, power, transportation, locomotives, you name it, we probably do it. We're still a gigantic conglomerate. With that being said, we have about 9,000 plus apps that we know of, probably double that if you count the stuff that we don't know about. And we have over 300,000 employees, not counting contractors. That's a lot of identities to manage. Actually, if you look at it, we're larger than some countries in terms of both revenue as well as employee count, which I think is hilarious. And also over 1 million plus networked endpoints. And that's going to grow exponentially. We're probably going to see hundreds of millions of endpoints as IoT takes off, as well as cloud. So GE is a giant company, for that size getting that. And all that being said, we're seeing stuff like this in the industry. We're seeing things like 14 million customer records on Verizon being exposed, right, because of an insecure cloud configuration. The federal government leaking sensitive information through S3. I mean, it's going on. And so given our large attack surface, we're really worried about this. And not only that, but the global landscape is not looking great either, right? So the non-cloud landscape, the number of breaches is going up every single year. Cybersecurity is now at the forefront. If you turn on the news, they're talking about the Equifax breach. And this one is not anything cloud related. It really is there to show us, oh yeah, traditional vulnerability management does count for something. We need to defend not only cloud, but also the traditional security spaces as well. This is what it feels like sometimes working in security. Right, the whole building is on fire. We don't know what to manage, how to defend it. But our SIM is saying they don't find, there's no events available. There's no new events. So, what I really want you guys to take away from this presentation, there's a lot more after this, is don't secure the cloud, but leverage the cloud for security. And the big difference here is when we approached it back in 2013, 2014. We saw cloud as just a new environment, right? It's a new data center. So let's go secure. Let's impose all these security controls on cloud so that we can get it up to where our data centers are, right? So let's go install those network IDS taps, right? Let's go install, McAfee everywhere. Let's do all these things that we used to do that we're comfortable doing. What we should have been doing is leveraging the cloud for security. The cloud is the best thing to happen to security in a long time. It presents to us a lot of things that we couldn't do before, and I'll get into that with the new model. So this is the traditional defense in depth model. You guys are probably familiar with it. It starts with policy and awareness, right? It should be the cornerstone of any good cybersecurity program. And then it moves into the physical space, right? So that's your physical security around your data centers, your offices. Then you get into kind of the network-based controls, right? So that crunchy exterior everybody talked about for a while with DMZs, firewalls, IPSs. Then you get into your internal network, right? And that really middle ring. That's your traditional vulnerability, network-based vulnerability management, your IDS infrastructure, right? Your IPSs. Subnetting counts in there as well. And then you get into the the host, the app, and the data. Well, in cloud, those things go away. You don't have to worry about the physical infrastructure because AWS takes care of it or Azure takes care of it, right? You kind of buy their security, so to speak. The perimeter largely goes away, right? You're not installing firewalls anymore. You're not managing really any kind of route tables or subnetting. I mean, you can, but it's mostly code. And then you really don't have any control over the underlying network. If you actually look at the network specs that AWS, Azure, and GCE use, it's all software-defined networking underneath. There's no way to really tap those networks and get the traditional visibility that you would get before. So we're kind of in a pickle because a lot of our controls lived in those three areas, right? So what do? We have to rebuild the model. So I'm presenting for the first time the IS Cloud Defense in Depth model. So it starts again with policy and awareness, right, cornerstone. And But then it moves into this new thing I call, and this is a new concept in cloud that I'll get into in more detail, but essentially it gives you that perfect asset management database you've always wanted. After that, you get into the cloud configuration level, also known as, I call it the enforcement level on the cloud plane. And then you start seeing more traditional things, right? You see your identity level, right? Identity is the new perimeter, right? Chris was huge pointing that out. Then you get into host, right, app, and data, which don't change much, but there are some changes. I actually added this slide in last minute. I got the question when I was rehearsing, what's the difference between IaaS, PaaS, and SaaS? And how do I adjust the model to fit all three? Easy. IaaS has the full stack I just showed you. The only thing you change for PaaS is you take out the host, the server level, the host level, right? You don't have to worry about that anymore. You kind of punt that over to the provider to manage, right? And you're like, well, I really want my AV on my server. Don't worry about that. AWS has 2.5 billion reasons now to care more about the host than you do. When you move from PaaS to SaaS, it takes away the application, right? You're buying the application stack from the provider, right? So you no longer have to do code reviews and worry about deployment pipelines, right? The provider manages a lot of that for you. And as you go down the stack, the controls don't really change. You just have to worry less about them. And so a lot of people really worry about SaaS. Like, how do I defend SaaS? It's completely different. I don't know what I'm doing. But that's largely because nobody really quite understands how to secure the cloud configuration level, and then most of us are pretty weak on identity, to be quite honest. So let's dive into policy and awareness real quick. I'm not going to get too heavy into this because I believe the speaker after me is going to do a little bit more deeper dive into this. But as an architect, I'm not a compliance or policy guy. I wouldn't go into that space. But from an architecture level, what we did is we built the 10 commandments for cloud security. What does that mean? Well, we took our large policy document, cloud security policy document, and we distilled it down to the 10 things we should never, ever, ever, ever see in a cloud security deployment. The first one being, I'll give you an example here. Thou shalt not have public S3. And I don't mean don't host things like public websites in S3. I mean, don't expose public permissions. Don't expose public right in S3, right? It's the stuff you should never, ever see. List objects is also a big one, right? If you want to, it goes back to the old directory listing days of you should never allow directory listing on your storage containers. But it's amazing. In AWS, a lot of developers make this mistake. They're like, what permissions do you want? And they just check every box. Like it's a great thing. And there you go. You can all of a sudden, an attack vector is, I'm just going to upload to S3 because that's now a thing you can do. Another example is, thou shalt not expose risky ports. And this one, goes back to the old DMZ days of, be very careful what ports you expose to the internet, and the cloud is no exception. So really no explanation needed there. And notice how the formatting of these guys, they're very simple, they're very to the point. They don't need a lot of additional explanation, right? Maybe a little bit of clarification underneath about what's considered risky or what permissions are not okay. But at the end of the day, you can easily reference them. And then finally, I'll get into this in more detail, but thou shalt tag resources. I love this one. Tagging is the new killer feature for security, and I'll go into how you can use tags to better secure yourself in cloud. Over the last couple years, the cloud providers have gotten a whole lot better in giving you all the resources you need to become compliant with whatever regulatory frameworks you need to become compliant with. Back when we started 5 years ago, they didn't have any of this, and it was terrifying. It was the wild west. But now if you just Google search, you look on Amazon's website, I provided direct links to almost all of it, right? So if you have HIPAA regulatory environments you have to deal with, right? Amazon has all the boxes you need to check and all the configurations you need to check, right, to become HIPAA compliant or PCI or what have you. Really, really nice. So, and just like Chris said, it's all out there on the internet. To Google search away. I gave you a couple examples. On the visibility side, this is where things get kind of change, right? And this is where things change from the old data center mindset. I like to say that perfect visibility is the new normal. What does that mean? Remember the old data center days, and actually I shouldn't say old because we're still living it today to a certain degree. How do I figure out what's on my network? Well, you can look at network IDS logs, right, which means deploying a whole IDS infrastructure, keeping up with that. You can do active network scanning to figure out what's in your network. Topology mapping, right, you take all that data and you plug it in, you get a pretty map. You can run agents on everything, right? And then at the end of the day, though, it comes down to, is my configuration management database any good, right? Does all that information add up to be anything I can use for security purposes? And then on top of that, if it changes, can I trust the change tickets to be any good on top of that? And a lot of the times it came out to be no. We had our cert, take a look at our CMDB and our configurations that we had in place, and they were completely different. So that was a huge problem. Our asset management program was in shambles. Well, thankfully, in cloud, you're a couple API calls away from getting perfect visibility into every single configuration, object, instance, everything. How do you do that, right? That sounds amazing, but nobody ever seems to talk about it, so how do I do it? There's kind of two halves to this equation. You have the top half, which is, I would say, cloud provider provided. So like Azure, for example, has their own set of services. We're an AWS shop, so I listed the AWS ones on top there. But they'll give you basic logging around what's changing in your environment from a configuration perspective, but also an alerting perspective. They'll give you flow logging. But really the interesting part is down bottom, and I call that configuration auditing. What that entails, and you can see actually here, SecurityMonkey, Cloud Custodians are tools you can use, open source tools you can use to do this today. Anyone here from Capital One, by the way? I love you guys. Cloud Custodian is amazing. But there's also paid alternatives like Divvy Cloud and Evident available as well. But essentially what they do is you plug it into your cloud environment, you give it credentials to go do this, and it enumerates everything in your cloud, and along with all of its configuration properties, all the permissions, it gets everything. And then from there, you can actually punch in your 10 commandments or other policies you may have and say, we should never see this, we want to alert on these things. And then you can take actions on them as well. So it gives compliance a really nice dashboard. And I'm actually surprised like a cloud service provider hasn't done this yet. But our compliance team has a really nice dashboard of all the configurations and all the configurations that are out of compliance. So that way they can track it down and start to remediate security risk. And this is where I get into tagging as a new killer security feature. I remember just a couple of years ago we had an incident, and the cert had to track down an IP address, right? So they linked a signature firing on an IDS to an IP address, and then they have to spend days figuring out who the IP address belongs to, which app it's a part of, what's the risk level. It's a nightmare. These guys, they spend most of their day pretty much playing detective, trying to figure out what's what. When you operate in cloud, you can tag almost every resource with metadata, right? Things like an application ID, with an owner, with a risk level. You get where I'm going with this. So that way, if there's an incident, right? Let's say you see something weird in CloudTrail, or if you see something out of compliance in your SecurityMonkey installation, then all of a sudden you can track it down to the right person to go remediate it. And it's almost instantaneous, right? The information is right there. And if you integrate those into your other tools, like your identity management tools, or into your ticketing processes, it's all automated. Another use for tagging is you can identify things that are just not normal, right? If all of your developers are tagging, or you're forcing that they tag, and you see 100 or 200 servers pop up that aren't tagged, you can easily know that's weird or out of the ordinary. This happened, I think recently, where somebody got billed $6,500 because their credentials leaked, and somebody decided to spin up a whole Bitcoin mining farm on their AWS account. So it took him a couple weeks to actually track it down and figure it out, and by that point, the AWS refunds your money. But it was not fun for him to deal with. So if you had tagging in place and a lot of the security tools I mentioned, you would have caught that minutes after it happened. So what do we do with all this visibility data, right? So I mean, it's great to look at dashboards, and it's great to put it in front of your CISO and be like, here are all the problems with the enterprise. But how do you do anything with it? This is a car driving off the road. What saves them are the guardrails. We need guardrails for a cloud, and so that's what GE has built. We call them the cloud guardrails. what they do is they take the visibility information on the left. So the events on the left should be familiar to you. There are 3 of our 10 commandments that I presented earlier. The tools like SecurityMonkey or Cloud Custodian allow us to actually define actions. So when we see an event that we don't like, that violate policy, we can take actions on those events to reduce our security exposure. So for example, let's say there's public write on an S3 bucket. We can fix the permissions in real time, literally seconds or minutes after the event occurs, and then email the asset owner or the person who made the change and tell them that's not okay, but here's the right way to go about what you're trying to do. And it accomplishes 2 things. It eliminates a lot of security risk, but it also acts for security awareness and policy awareness at the same time. So in the last example here, the instance not tagged properly, this is a case where you might be a little bit more lenient around this, right? So you may just want to just email the owner, right? Let them know what the tagging policy is, and give them 72 hours to go fix the tags before you turn it off. So, but this is where I think a lot of the power of cloud really shows itself, is that you're starting from a place of perfect information, which means you can actually move into perfect remediation based on your compliance policies. And this is showing, the same tools I pointed out before, they support this whole feature set as well. So a lot of the ones that do the visibility piece can actually take actions on that. When it comes to identity, I'll defer to Chris. Chris did an excellent job. Identity is the new perimeter. In IaaS, PaaS, and SaaS, you're one API call away from complete disaster. So if your root credentials get out, they can do anything, right? I mean, that API is not protected by a firewall, right? You can't filter by source or desk, right? The only protection you have is how well you protect your identity. The fundamentals all apply here. There's really no secret sauce to identity in cloud. It all goes back to the basics, right? Are you using MFA? Are you federating your identities? Are you using the right policies and groups, right? Not giving everyone the same access. Please, please, please don't use static API keys. But if you do use static API keys, rotate them out regularly. And then provision access for least privilege. There's a couple tools out there that allow you to do this dynamically, which are really cool. I think Netflix has one. I forget the name of it. But allows you to, based on how the user is acting and what they have access to, it'll shrink or grow their permissions dynamically. So there's a lot of really good stuff in this space. Here's an example of how you can use federation, as well as what Amazon calls STS, or the simple token service, to, let's say, securely authenticate yourself. We've moved to this model almost entirely at GE. There's no other way you can currently access the cloud programmatically. So essentially, if you work from the client app up, they authenticate via SSO with their normal, SAML credentials, or with a functional account, right? That has limited permissions. It checks on the back end with our, our identity store, returns them a token. They pass that token to Amazon to get a temporary API credential that they then use to actually provision their resources. And it allows you, in many places, either revoke the credential, right, revoke their access. Everything is time-bound, so you can set that to only be effective for 30 seconds, a minute, right, 3 hours, however long you need that temporary token to be active for. But that way you never have keys floating around, right? You have to do a little bit better protection of protecting your IDP and your usernames and passwords for your corporation. But you've always had to do that, so it integrates nicely with what you currently have for identity controls. Here's 3 videos that explain IAM way better than I can. Plus I only have 30 minutes. This would take 3 or 4 hours. But both Amazon as well as a bunch of random people on the internet have go deep into how you actually structure it, how you architect it, how you design it, and how you build it. I thoroughly recommend these 3 videos. Okay, moving on, the host level. So this is where things start to look more familiar. So I'll go over what changes in cloud, but a lot of the old world rules still apply. So, when it comes to the host, you still have to harden it, you still have to patch it, and you still should run some kind of endpoint detection response tool or AV, HIPS, pick your poison, right? But there's this new thing in cloud around, it's actually kind of a debate these days architecturally. There's no right answer here. It depends on your organization. Do I run gold images, or do I use configuration management and standard images that Amazon provides you? I'll break down why it's a debate. So the gold images one, essentially your centralized cloud team builds, I would say, images that your developers have to use, right? So they build either nightly, weekly, or monthly new images. Your developers go into their portal or hit the API and use those images. And they're pre-prepared, they're pre-hardened, they have all your tools on them, they have all the agents running. They're fairly locked down. The cool part is this process is largely automated. You can use something like Packer, and this is what a Packer script looks like to define what the security controls within that image look like. This is actually the Packer script for the DoD's images, which I'm surprised they put on GitHub. But yeah, if you want to use the DoD's hardened Omni images, they're right up there. The second option is config management. And these should look more familiar. Chef, Docker, Puppet, right? I would say if you're going to go this route, give your developers the cookbooks they need to be successful, or the Puppet playbooks they need to be successful. Don't chastise them for not putting your security tools on their servers if you don't give them ways to actually go do that. So we found it to be pretty successful if we give them deployment packages or cookbooks ahead of time, and then them using that. We go the golden images route, so I believe in config management, but the golden images seem to work pretty well. And then actually, to Chris's point earlier, serverless is coming, right? PaaS is becoming more and more of a thing every single day. We have a lot of deployments in proof of concept and pilot right now that are going full serverless. For us, it's AWS Lambda, right? You give them code, you give AWS code, they'll run it for you. You don't have to worry about the server. So it's up to you. I think there's always going to be a place for running and managing servers, but in the future, over the next 3 years, it'll become less and less of an issue. When you get into the traditional app space, there's a lot of people that have explained this a whole lot better than I have. This was a talk done, DerbyCon. It was another security conference last year around how DevOps and security interact with each other in today's enterprises. And this is the current image, right? So DevOps moves a lot faster than security can keep up with it, right? At the end of his presentation, he said that we should all work together. In my mind, DevOps means better code security. And it all depends on how security reacts to the DevOps folks. The key here, and I'll show you a very complicated diagram about how to deploy this properly, is you need to get into their CI/CD pipelines early. And you need to integrate really, really well with them. So the security components are actually highlighted here. It looks like, as well as the external vulnerabilities associated with it. Finally, with data, it's our last line of defense in cloud. If you're at this point, if you failed so hard that you need to defend the data, well, I'm praying for you. But there are ways to defend it. So this is a distributed KMS architecture, and Chris again mentioned a pretty good way of protecting keys, but also encrypting data in the right spots. Here, it's all about blast radius. If you're going to get owned, if your other security controls are going to fail, what's going to be stolen, what's going to be lost. KMS allows you to, or any key management system for that matter, allows you to contain that blast radius, right? So if your S3 gets popped, right, use one key for that particular S3 bucket, right? If your app gets popped, make sure your database has a separate KMS key and separate encryption mechanism. And this is all up to you, right? This is either between you and your app developers, or you mandate it down from a security perspective how you want to see this. But like I said, if you get down to this point, then everything else has failed. You're in a bad spot anyway. So with that being said, thanks for listening. It was very quick. It was a lot of rambling. I'm going to post a lot of this content on my blog. So all the resources you saw, you didn't have to quickly take pictures or jot it down. It'll be up there. Yeah, thanks for listening.